everyone. This is Nika Christine Bingel, and today I'm going to present my part for the discussion. But before that, let me ask you a question. What is forming and shaping processes? Well, forming and shaping processes are manufacturing methods used to change the size, shape, or geometry of raw materials like metals, plastics, ceramics, or composites into desired products without removing material, unlike machining. These processes rely on applying force, heat, or pressure to reshape the material. Under the shaping and processes is forging. So forging, it means pressing, hammering, or squeezing heated metal until it takes the desired shape. Like see for the example in the image, it visually demonstrates the forging process where a heated workpiece is compressed between tools, like for example hammer or press and die, to achieve a desired shape, highlighting the principle of plastic deformation under compressive forces. Now, let's proceed to the characteristics of forging. So, there are four characteristics of forging. First is we have it uses compressive stress, not tensile or shear. So in forging, the metal is shaped by squeezing or pressing forces, unlike tensile stress, which stretches, or shear stress, which slides layers. Forging relies on compressive forces to plastically deform the material. So in this case, this prevents cracking and ensures the material fills the die cavity completely. Second is it can be performed hot or above recrystallization temperature or cold room temperature. So, hot forging, the metal is heated above its recrystallization temperature, so it becomes soft and easy to shape. This also allows new grains to form, removing strain hardening. So, in cold forging, it is done at or near room temperature. It increases strength through strain hardening but requires higher forces and is usually limited to simpler shapes. The choice depends on material, desired properties, and shaped complexity. It improves mechanical properties by refining the grain structure. So during forging, the metal grains of the metal are elongated and aligned along the flow of the material. This results in grain refinement, which enhances its strength, toughness, fatigue resistance, and also its defects like porosity are also reduced, making the material more reliable and stronger. Lastly, it produces stronger and tougher components than casting or machining. So, in casting, metal solidifies in molds but may have defects like porosity, weak grain boundaries, or inclusions, while in machining, only shapes the material by removing exists. It doesn't improve material properties. While in forging, it enhances strength and toughness due to grain flow and compressive shaping. That's why forged parts like crankshafts, gears, aircraft parts are used where safety and durability are critical. So, in short, forging relies on compressive forces that can be done in hot or cold, and it also improves grain structure and makes parts stronger and tougher than other manufacturing. Now we're done with the characteristics and let's move forward with the types of forging. So first is we have the open die forging. In this process, the workpiece is placed between flat or simple shaped dies. The metal is repeatedly hammered or pressed until it reaches the desired shape. It does not produce very precise shapes, so machining is often needed afterward. Like, see for an example, a blacksmith forging, like shaping a hammer head or shaft. So inito na ang hammer or ang metal before pukpukon siya sa hammer. Second is the closed die forging or impression die forging. So in this case, the metal is compressed inside shaped dies that enclose the workpiece. The metal flows and fills the die cavity, producing more parts with more accurate and complex shapes. It also produces near final or near net shape needing little or no machining. For an example, the automobile parts like crankshafts, gears, and connecting rods. In short, open die forging, simple dies, less precise, more manual like the blacksmith work, while the closed die forging, shaped dies, more precise, good for mass production. So, if papilion ta, mas better ang closed die forging. So, the third one is the press forging. So, in press forging, gradual and continuous pressure is applied using a press. Kay from the word press, imurang iduot or pinduton. So, the deformation happens slowly, which allows better control over the shape and dimensions. It ensures uniform shaping throughout the metal and is also suitable for large or precise parts. So, for an example, are large turbine shafts and also the structural parts. So, the fourth one and the last one is the drop forging. In drop forging, a hammer is being dropped onto the workpiece placed in a die. So, the high impact force deforms the metal quickly by filling the die cavity. So, it is faster than press forging but less controlled and flush or exists metal is usually formed. So, an example of these are wrenches, crankshafts, and connecting rods. So, for simpler understanding, press forging is slow, controlled pressure, accurate, and uniform, while the drop forging is fast, high impact hammer blows, quick shaping, and is commonly for tools and automotive parts. So, second type under the forming and shaping processes is rolling. Rolling is a metal forming process where a heated or cold workpiece is passed between two rotating rules. The rules compress the metal, reducing its thickness and at the same time increasing its length. It is commonly used for producing sheets, plates, and strips of metal. So makita nato dira sa kilid is the picture beside nga process sa rolling. If forging has characteristics, rolling has too. First is one of the most widely used industrial forming processes. So, rolling it is very common in industries because it is efficient, economical, and can produce large quantities of metal products. Second, it produces sheets, strips, plates, rails, rods, and structural sections. So, by passing metal through rulers, we can make different products like thin sheets, wide plates, long rods, rails, trucks, and even L-beams used in construction. Third, can be hot rolling or cold rolling. So, hot rolling is done above recrystallization temperature, making the metal soft and easy to shape. So, it is used for large products like plates and beams. So, in cold rolling, it is done below recrystallization. So, the temperature which improves surface finish and strength, but it requires more force. So, common for thin sheets and strips. So, types of rolling. First is we have